Hello, hi guys, welcome to my channel. In this video, we'll be discussing how to create a virtual private cloud using Terraform. In fact, we'll be creating a VPC along with multiple EC2 instances. To accomplish this, we need to create several resources including VPC, a subnet, an internet gateway, a route table with its association, a security group, and finally a EC2 instances. Uh, so let's go ahead and I'll show you the design which we're going to create. So yeah, this is the architecture of what we're going to achieve on this tutorial. So let's start. Since I will explain about AWS initially. If you guys already know, that's okay. But if you don't know, I'll just give a brief explanation of how it works and what it is. AWS is a comprehensive, evolving cloud platforming uh, computing platform provided by Amazon. It provides a mix of infrastructure as service, platform as service, and package software as service offerings. AWS services can offer organization tools such as compute power, database storage, and content delivery services. For instance, for computing power, AWS offers like EC2, which is called Elastic Compute Cloud, that provide resizable compute capacity in the cloud. And for storage, they provide Amazon S3, and for database solution, they provide variety of solution like Amazon RTS or DynamoDB relation database service or NoSQL database service. And from networking part, they provide service like VPC, which we are going to cover in this tutorial, which will basically allow you to provision a logically isolated section of AWS cloud where you can launch AWS resources in a virtual network, which you can define. So let's talk each one by one, and let's talk about VPC. So I already explained it's a virtual network dedicated to your AWS account where you can launch AWS resources in a virtual network that you can define. You have complete control of your virtual networking environment, so including selection of your own IP address, creation of subnets, and configuration of route tables and network gateways. Subnets, within our subnets, we have two type of subnets, public and private. So we are going to only cover public in this tutorial. So we use a public subnet for resources that must be connected to the internet gateway, and a private subnet for resources that won't be connected to the internet. And internet gateway, this is like a city airport or seaport, uh, connecting it to a outside world. A internet gateway is like a horizontally scalable, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. And the route table, these are like the city traffic signs directing traffic to different parts of the city. A route table contains a set of rules called routes. These are used to determine where network traffic is directed. Each subnet in your VPC must be associated with a route table. The table controls the traffic for the subnet. And we also have to have a subnet association. This is the process of associating a route table to the subnet. It's like assigning a specific traffic rule to a particular neighborhood. This determines how the traffic flows in and out of the subnet. And the security group, these are like the buildings. These are like the city. You can think it of as a city police force providing security to the city. Like a security group acts as a virtual firewall for your instances to control inbound and outbound traffic. When you launch an instance in VPC, you can assign up to like 5 sub security groups to the instance. And finally, the EC2 instance. These are like the buildings within our city. Like EC2 instance is a virtual server in Amazon Elastic Compute Cloud for running applications on AWS infrastructure, basically. So in our journey, we'll be creating our own city like VPC, defining our neighbor subnets, setting up our city connection to the outside world, which is called internet gateway, and putting up traffic signs like route table, and assign traffic rules to neighborhood, which called Subnet Association, and setting up our own police force, security groups, and finally constructing our buildings like EC2 instances. So remember, each of these components plays a crucial role in our AWS infrastructure. Understanding them is a key to architecting and managing our applications effectively in the cloud. Now let's continue our creation of VPC and multiple instances using Terraform. So let me explain about Terraform now. So Terraform is an open source infrastructure as code software tool that provides consistent CLI workflow to manage hundreds of cloud services. It's basically It allows developers to manage infrastructure through a version system, like versioning system, improving the workflow and providing a source of documentation. So so I have created a GitHub repo for this. So let me show up the code. So this Terraform uses text files like .tf files to describe infrastructure and to set variables. These are called Terraform configurations, and this will end with .tf. If you can see here, these are the .tf. These use these configurations to create, change, or improve infrastructure. So Terraform is widely used by DevOps professionals like me for writing infrastructure as code and automating the process of configuration management. It supports variety of cloud providers. You can if you just come here and search for the providers for Terraform, you can see plenty of them: AWS, Azure, Google Cloud, and a lot of things are Terraform supports all these cloud. We can manage the infrastructure as cloud. So okay, so let's discuss about the code which we have I have written. So this code is written in HashiCorp configuration language HCL used by Terraform, um, a tool for building and changing and versioning infrastructure safely and efficiently. Terraform can manage existing and popular service providers as well, like custom in-house solutions. The code I'm showing here is a Terraform script which has three files. The one would be variable. This is the main file, and this is a variable file, and this is the output file. This is the main file where we're going to assign. We're going to go through each section. So it's create environments in AWS. The complete details which I explained you, we're going to do this. So let's go through each section. So this is a provider AWS. This is, and the region would be where location. So this is the variable. I have written variables here, so I'm picking up the location from here, and which would be AP South, and the same vice versa for the others. And AWS AF. So let's go the provider AWS. See here, this block configures the AWS provider, which is responsible for creating and managing AWS resources. And the region attribute specifies the AWS region where the resources will be created. So, and the resource AWS EIP is, which is nothing but elastic IP address. So this block creates a AWS elastic IP for EC2 instances. IPs are static public IP4 address that you can allocate to your AWS account and then associate with your instances. The count attribute is set to where the count attribute is set to where, like here. So this is count. This deals with how many instances we're going to create. So this is AWS instances with creation. This is the name, and this is the demo. Demo server is the name, and here is the demo elastic IP address name as well. And AMI is nothing but let's talk about prerequisite first. I think I forgot something new. So let me show you the prerequisites. But this AMI is nothing but what version, what image we are going to pick up. So if you come here and look for the AMI in the Amazon console, you can see here. So I'm using this AMI for now, which is a free tier. It's a T micro part. Like we have different type of server types actually. Let me go and show you how much. So these are the different types of server types the Amazon provides. We are using T3 micro, which is actually in which is actually you see here, yeah, T3.micro, 2 CPUs and credits, and like only 1 GB memory and up to 5. So but it's basically which comes up in our free tier, so that's why I'm using it. And I'm going to use this AMI in our code. So let's go back. So I already have created a AMI OS name here variable, and um, this is the one which we're going to create. So I already copied it from here. So that sounds good. And let's go to the next part, and the key name. This is the key pair. We need to create a key pair as well to make sure. So I have created one which is demo3. You can always go ahead and create something like here, which is pretty simple, and then create a pair, and we'll be using the same name, and it will, this basically will be used to connect to the instances from your local. uh, so that's how it works. And then the instance type, um, and basically AWS instance type. This block creates EC2 instances basically with taking AMI name and key name and instance type, and other parts like a subnet and VPC group and everything. And I also provided some few details like after the instance has been created, I provided a user data to start to run these commands, initiate the commands, and to make sure to install the m update, update the m packages, and install unzip and JDK11, Docker and Docker Compose in and starting and start the Docker part. So that's how it works. And then we'll be creating the VPC here. This is the resource. This is the AWS VPC. This block creates AWS VPC and dedicated to your part. And that's what the CDA block will be. This part I think attribute specifies the IP4 network range for the VPC in CDR notation, like CIDR notation. And next go to the AWS subnet, which this will be block creates a subnet within the VPC, which as I explained. So that's how it goes, and I provided the name for it, and this is the status block for this. We use this block for it, like we will be using the same. Once we created the VPC, we'll be using the subnet, and then the internet gateway. That's how it. So you don't need to worry about it. So I actually got this code from the Terraform. If you provide something like, let's see, yeah, here this is a provider, and they have provided complete source code and the documentation here. If you have any doubts or you want to any changes to this code, you can always go here and look for the changes. There are plenty of details here you can go through, and I think you can Google it as well. It's very easy, and it's very you can find the documentation everywhere. So that's not a problem. So let's go back, and then we'll be creating the route table as we discussed, and then we'll be associating the subnet with the route table and creating the service group. And here the main part I have to talk about is this is the ingress. So this basically will be creating like this ingress block specifies rules for incoming traffic and to open these ports 2280.443. I just provided this for just for like demo purpose, but it depends on your requirement. And egress is something we need to, this block specifies a rule for outgoing traffic, and allows DFS is nothing. We just allowing the resources basically. And once we define all these resources, and I have created variables, and I have updated the variable name here, the location, OS name, key, and the instance type T2 micro, which I explained you before. And we are using 10.10 version in this demo. And this is the VPC and the subnet. Subnet would be one similar to the VPC, and just will be creating one more will be 24, and this is the 16 part like. And then the subnet availability zone as well. This is the availability zone. And the next part would be output. So I have created output value so that whenever the Terraform creates the resources, it will output this service IP address right away here. So I'm going to share you those details in quick minute. So let me go back to the quick here. So I have covered this part, and we'll be creating. We need to have a Terraform user in IAM to have admin access to create resources. Let's go to that point and create one. So search for the IAM here. I already created one, but I'll show you how to create one for you, but I'm still going to use the old one. So I have created one here. This is the one which I already created, and then click on add users and just give the name admin user, and then next attach policy directly, because we need to have complete access to create resources in AWS. We need to give complete access to it, and then click on it, and then yeah, create the user. So once you create the user, there is one more option we need to do. Just go into the user and then go to the security credentials. You will find something like access keys. You need to click on create access key. We need to create access key using command line interface, and then accept this confirmation, and then do next, and just add a similar name like a tag. Then it's going to create a user. So that's how it works. So yeah, that's how it works. So now after this, so once we created this, we'll be storing that in our local. So we'll be using this to connect to the AWS here. So if you go back to the design document, let me show you. Yeah, here it is. So this is the Terraform AWS integration. So we are using the MacBook in my instance, and then the Terraform will be will be pulling the access keys and secret keys using this access keys and secret keys which we created. Terraform will be initiating a connection to AWS cloud, and using a Terraform init, we'll be downloading the AWS plugin. I'm going to show you those part in a real quick time. So and I also explained you about the create key pair and AMI name. How can you get it? So and the next part would be AWS CLI installation. So there is a URL which is very useful, which is provided by AWS. Since if you come here, if you click here, so they have provided documentation. It's pretty simple. I installed using this. Basically, you need to download this package file for Mac, and you have something else for Linux. We have the similar Perl command, and for Windows as well, you have a different command for it. Let me show you. So it's pretty simple. You can follow this, and you can get your Amazon CLI installed on your local. And the next part would be Terraform installation. Terraform installation is also pretty simple. So we can go to this document. So I'm going to provide all these URLs in my YouTube description. The video description, you can find this here, so you don't need to worry about it. So these are the for installing Terraform, I need to run these commands, and which I already did. So you don't need to worry about it. So so I already created a GitHub repo for this. For the code, you can use this code. So we covered AWS account, CLI, and configured. So let's start. We defined all the resources like in our Terraform manifesto. We can use the. So let's configure the CLI. So I'll just run the AWS version to make sure. So this is the version which is already installed. I installed it, and let's do the Terraform version as well. See, so both AWS and Terraform got installed in my local. So now let's do. So I'm right now in this present directory, like in this way the files has been located. So let's do Terraform init. So let's do Terraform init. Oh, okay. So it's basically it will initialize the complete provided plugins from AWS. So that's how it's. So basically, Terraform is successfully initiated. So now you can. There are commands which will be very useful for you. I think I will say format. So this is format button. If they have any syntax errors internally within your file, if you run this, so you see it will update it. So that's how it is. And then there is a validate option where you can validate whether the configuration looks fine. So let's run that. Yeah, it's there. So I think you have to do, before this you need to do AWS configure, and then actually it's better to do you have to provide the credentials which we created. Let's go back and let me show you the. So we created this, if you remember, and I copy this here and then run it, and then I copy the secret key as well. And the default region which we are going to use in here is the one which we are using here is AP South one, so that should be it. And then we can use the JSON format which will be normal. And now do Terraform plan. So this is the command actually will be showing you what it's going to create. So let's maximize this so that you can see. Yep. See here, once we ran this command, it's basically trying to show up what will be updated. So it will start creating the heap, and yeah, this will be created, and an instance will be created, and then yeah, these are the instances. We have two instances. Remember, I provided. If you go to the main file, I have provided the count as 2. So this particular will be creating 2 instances. That's why it's creating 2, and then the internet gateway. Yeah. So and then the internet gateway and route table and route table association, and we have security group, and finally I think yeah, and AWS subnet, and then the VPC. So these are all will be created. So the cool part is we can always make changes to this and apply it in very few seconds or in a minute. So that's so crazy. We have a good control of your infrastructure. So that's how you have to use Terraform. I'm 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 literally initially when I started using this, I'm very impressed with this. So I think I'm going to use this for any automation, infrastructure automation going forward. So I hope you guys will be also following the same. So let's do now once we planned it. So let's do. So let me show you the first part. Whether let's go to the AWS services. So I'm in right now Mumbai zone, which is AP South 1. And if I go here in the EC2 instances, I don't see anything running, right? So let's go back and run uh, Terraform apply. Okay, I'll not do that. So once you do the Terraform apply, it will initialize everything and start creating the resources. So it will ask for the railway confirmation. You just type S, and then it should be it. It starts creating the resources. So it's gonna take some time. Let's discuss one more thing. I think I have forgot to explain you one more thing. I think uh, so. There are multiple meta. One second. Let me show meta arguments which you're going to use in Terraform, which would be useful for you. So I'm going to explain you about that. We have like this is the documentation. It's pretty simple. If you want to find anything on Terraform, you just Google it. You will be able to find anything on Terraform. That's how documentation. That's how open source they are, and it's very easy. And there are, if you can go to communities or Stack Overflow, you can find any issues as well. So let's go and depends on. This is something depends on. If we have if some resources has a dependency on the other part, we'll be using depend on, and the count we already went to the count where we want to create multiple instances. We provide the count, and for each model it's basically you want to serve like for like fixed pool of compute instances without writing a separate block for each one. We're going to use this. And the provider is nothing but the AWS and Google, which I showed you. We have multiple providers supported by them, and that's how it is. And the life cycle is blocked within, like you can we can maintain a behavior. We can customize using, like, let's for example we create before destroy, um, like and then and there are like multiple things as a prepare and destroy, and also ignore changes. We can use anything like for your basic implementation or your personal requirement. You can use this. So this documentation will be also useful. I'm gonna put this in the description as well. Let's go back and see. Oh yeah, so it's already created. Boom, it's created two servers. So let's go back to our AWS instance and find out whether it got created also in our resources. So let's see. Yeah, it's created. And yeah, so this is very cool. I didn't log into the AWS and do anything. So I know like how mad it is to going here and creating everything each one by one. So this Terraform is very super and very flexible to use. So also so if you go to one of the instances, it's gonna show you. So this is the elastic IP address which got assigned, and this is the instance has been created, and this is the VPC which has been created. And if you go to security, these are the ports which I opened, if you remember. And this is the security group rules. And if you go to the security groups, it's going to show you this part. Okay, let's go back. And then the networking part, if you go here, I think the network has been created, and this is the elastic IP. And you should see this everywhere. And if you want to see the elastic IPs here, you can go here, and there are two elastic IPs associated with two instances security group. So this is the security group has been created, and everything so as such. Yep, that's pretty much for this video. I think I covered all of the part which I told. Like, that's all for the video. In our next video, uh, we'll be exploring how to launch a Kubernetes cluster with using Terraform. Please let us know in the comments if you're interested in this topic. Thank you for watching and see you in the next video. Please do like and subscribe my channel so that I can do more videos. See you. Bye. Thank you.